This is a demonstration of the operation of a PLC-based detention pond pump control system for running two 480-volt three-phase pumps. And the operation of them through the logic in the PLC is based on the level of the water in the pond and the water in the street ditch. We have float valves in the pond. Shows pond empty. So when this is down, the pond is empty. If the pond is fuller than that, this will be up. If it's up high enough to have one pump going, this one will also be up. If the pond level is even higher, we need two pumps going, this one will be up. So all three of them up, both pumps will be running. We also have in a manhole the street ditch level sensing. We have one for street ditch half full and street ditch full. When the street ditch is full, both pumps are disabled until it gets down to below half full. So both of these have to be down for the pumps to operate. If it gets to the point when the pumps are operating, if the half full turns on, they'll keep running until it gets to full. And if that happens, the pumps shut off and it won't start back up again until both of them are down. So it's below half full. We're simulating the pumps by just using small contactor relays, and we have lights to show pump 1 and pump 2 on. When it's installed, we'll be using Siemens motor starters with electronic overload and with phase loss and all that. But for this demonstration, we're just using little contactors. Now I'll demonstrate the actual operation of the system with the flow valves. Okay, I'm showing how the float switches interface with the PLC to operate the pumps. And I have a string on each one so I can hold them up because I can't hold up all 5 at once. We're showing it with the street ditch being less than half full. The pond is above empty, and then it's filling up to the level where one pump comes on, so this goes up, and then pump 2 comes on. Now pump 2 specifically has a 3-second delay, so that if it tried to call for both pumps to come on at once, like if the ditch were full and then emptied, we don't want both pumps to come on at the same time. So pump 2 has a 5-second delay or a 3-second delay. If we go up to the 3rd level here, then both pumps are running. And they'll all stay running until it gets down to empty. So we're letting all 3 of them down, the pond goes down to empty, and the pumps shut off. Now if the the street ditch is full, so that would mean both of these up. Then, no matter what we do here, we're not going to get any pumps to come on. So let's say the ditch were full, and our pond is filling up. Gets up to the level where we want both pumps running. No pumps will come on until the ditch naturally lowers to its below half full. So now it's below full, but it has to be below half full for the pumps to come on. So it goes down to half full. The first one comes on, the second one's on a delay, and there's the delay. And if again the ditch filled up, so it's half full, they'll shut off until we get back to half full, below half full. Again, we had a delay in the pumps. The pump is just for that situation where they're only inhibited by the street ditch. We're calling for all 3 here, but the street ditch is full and then empty. We don't want both pumps coming on because it's very high current load when the motors kick on. So now we're going to drop our levels here. I want to demonstrate one more thing. They'll go down. Each time the pumps come on, it switches between the lead pump. Here we'll see that the pump 1 is the lead pump, the first one to come on. And then the next time it starts up, pump 2 is the one to come on. And it's got that little 3-second delay in it, so we have to wait for the delay to come on. So that'll come on, and then if the level gets higher, pump 1 comes on. So if we do it again, the next time it's opposite. So this is just to provide even wear on the motor. See, now 1 comes on first, and then 2 after it's 10-second delay. And again, no matter what's going on here, if the ditch gets full, it's going to shut it off until the ditch is below half. And that's it.